All right, everyone, welcome back to ECE410, Class 2, Part 2. In this lecture, we're going to develop a very common equation for this circuit here. Last one, we had the duty cycle at 50%. Now we're going to define the duty ratio as D. So that means if T is the period, right? Then the part of the period, this switch one here, we're gonna with the D with this one here. So if it's on for the D, that means it's on for the part of the period is DT. So for switch one, let's say this is number one here, and this is the number two here, right? So they're number one and two, they're complementary. So if that means if one is on, another is off, they're complementary. So if this one is on for dt time, this one is only on for t minus dt time, right? So we're gonna use the common d here. D could be anything from 0 to 100%. D is the dt ratio. So with that, let's for this one here, again, you know that is a VL over here. So is V in over here. If I use KVL over here, your VL would be V in. And over here for this circuit over here is the VL, right? And if I use KVL here, your VL would be V in minus V out, right? So if I use, let's say for this one here, this one is on for DT time. So then other one, the switch number two over here, which is on here, it would be T minus DT time, right? So that is the time for this both of them. So one is on for DT time, another one is on for T minus DT time. All right. So now if I go for here, switch one is on. Let's say switch one, this circuit over here, switch one on, right? All right. So then so W1 is 0 to dt. Now it's not t over to any definite time. D could be anything. So 0 to dt. Then you know that is VL IL dt, right? Then if I go replace the VL over here, so VL is V in, so is B in IL here, right? Then my if integration limit here is be dt, right? So that's for W1. And for W2, I'm on for now dt to t, right? Later of the period, right? Then your VL IL dt over here. So if I go one step further here, so your again it's still dt t. BL is V in minus V out IL dt, right? Now if you finish the integration over here, W2 would be V in minus V out times IL, and your time would be now T minus dt, right? So now if I add them together over a period, that should be 0, right? Okay, inductor cannot store energy over a period. So then we have over here we have V in IL dt plus I have V in minus V out IL T minus dt equal to 0, right? So now there's some common factor here. T and IL will be common factors, so I can cancel them out. If I cancel them out, and if I finish my algebra here, you can try by yourself. If I finish my algebra over here, my V out would be V in 1 minus D. So D is the dt ratio. It can be limit from 0 to 100% or 0 to 1, whatever you do it. And so if D equal to 0, you will see that V out is V in, right? If D equal to, let's say 0.5, which is 50%, and you will see that V out would be 2 times V in. You have seen it in the last one. When D equal to 100%, all right, or 1, then you will see that V out is infinite, right? So this is the very interesting point here. We're going to discuss in the class, and I would like to ask you why is that, and how do you what you make out of it. All right. So that's your common formula. So this is the very common equation for this circuit. V out V in over 1 minus D. So with the D, you can D means D ratio of this one here. So D is D ratio of this one here, how long this switch one is on. So based on that, you get different output voltage from this circuit. Okay, now this one over here, you can see that we don't have a perfect inductor here. Inductor has some resistance in it. So how do you formulate the equation when you have some lossy component into the ideal circuit we had? So this is what we're going to do in the class, and I would ask you to think about it. How do you incorporate that in your equations when you have RL? That RL could be here, then could be another component with the capacitor could be there too. So we're going to think about that too. And that's what we're going to do in the next class. In the class, we're going to derive the equation for this one. All right, that's all for today. I'm going to see you guys in the class.